Hello. Um, Anybody here who hasn't got a copy of the lecture notes? I've got some spares with me if you need. Anybody without a copy of the notes? Anyone else without a copy of the lecture notes? Um, I'm disappointed with the number of people turning up for lectures. Seems that not many people, excuse me, seems not many people are coming for the lectures. I mean, the fact that I'm podcasting everything doesn't mean that you shouldn't come to the lectures, right? I mean, come to attendance in lectures and attendance in exam classes is very important. Okay? So it's really, really important that you do come to lectures as well as the exam classes. One other announcement is this is week 3, so there is a week 3 feedback form in front of you. So just take a couple of minutes to fill in comments you have about this course. I would really appreciate that. So if you could, before you leave this lecture, if you could fill in your comments and give it to me before you leave the lecture, I would really appreciate it. Okay? Okay, guys? Now, today what I'm going to do is, I just finished an example class, and I found that many students are struggling to do questions on biases and MSCs. So what I'm going to do for the large part of today is to do some more examples. Are you listening to me, guys? Hello? What I'm going to do during the lecture is to hello? Which one is podcast? So it's this one? Okay, thank you. Okay. All right. Well, what I'm going to do, the large part of the lecture today is to do some more examples on biases and mean squared error, right? So hopefully this will help you to reinforce your knowledge on biases and MSC and showing that something is consistent or unbiased. All right? The first, all right, here we are. The first example I'm going to do today, where's my glass? Just a minute. The first example I'm going to do today is example number 10. If you look at example 10, which is over here, guys, example number 10 on the list of examples I gave you at the beginning. So this is example 10. Is this large enough? Can you read this from the back, guys? No? Yes? Okay. Okay, good. So you have a random sample from a uniform distribution on the interval theta to theta plus 1. Consider the estimator, which is the sample mean of theta. Find the bias, the MSC, variance, and check whether it is consistent. All right. So x bar is the sample mean. It's a possible estimator of theta. So the first thing I want to find is the bias of x bar. Remember, the bias is defined as this is the definition of bias. The bias is the expectation of the estimator minus the parameter that you're trying to estimate. Okay? So this is okay, guys? Okay, now let me ask you, this is where your memory comes in. I'm sure you guys have better memory than I do, old man like me. The expectation of xi for a uniform distribution is, you guys remember? What's the expected value of xi if xi is uniform? Don't you remember, guys? I thought you had better memory than me. No? Let me show you. Guys, for a uniform distribution on the interval from A to B, the expected value is A plus B divided by 2. So in this case, A is theta plus B is theta plus 1 divided by 2. Yeah? So yes? right, guys. So X bar, so the bias turns out to be equal to a half, which is not equal to 0. Therefore, X bar is a biased estimator of theta. Yeah? Are you guys with me or not? Yeah, all right. All right. Now, so the bias is not equal to 0. The next thing we need to find is the MSC. To find the MSC, I'm going to take this off. I'm going to put this over here, guys. Do you guys remember this formula? Where does it come from? Do you guys remember this formula? We did this while ago, right? Yes. The MSC is equal to the variance plus the square of the bias. Now, we showed just now that we just showed that the bias is equal to half. So the square of the bias is a quarter, right? So what remains to be found is the variance of X bar. So this is variance of yes. All right, and this is now we know that each xi is uniform. Now let me test your memory one more time. The variance of xi for a uniform variable is yes, b minus a divided by 12, which is theta plus 1 minus theta squared divided by 12. Okay? So this is so the MSC of the estimator X bar is equal to 1 divided by 12 and plus a quarter. And this right, as n approaches infinity, it approaches a quarter, right? And therefore, X bar is therefore X bar is a biased estimator and is also an inconsistent estimator, that is a not consistent estimator. Okay? Now let's return to the same question. Now, I know this question is not on the list of examples. How can you make this estimator? I know this estimator is really bad because it's not unbiased and it's not consistent. So it's in both, with respect to both criteria, it fails. It fails both criteria. So it's really a bad estimator. Now, how can you make a good estimator out of this? Do you guess what? Do you guess? Now, we have an estimator. We have an estimator that has bias not equal to 0, and the limit of the MSE is not equal to 0. So, to make sometimes, you know, it's possible to, in such situations, it's possible to find a new estimator that has all the good properties. So I'm going to show you how. So let y defined as x bar minus a quarter, right, denote a possible estimator of theta. Now, let's look to see what kind of properties this new estimator has, which I denoted by the letter y. So the bias of y now, we know from, if you go back to the slides that we had earlier, we know from here that the expectation of x bar is equal to theta plus half. So, sorry, did I say quarter? It should be, sorry guys. It should be half, not quarter, is that right? Sorry, it should be a half. Now, if you look over here, guys, the expectation of x bar is equal to theta plus a half. So this implies that y is sorry guys. So it implies that the new estimator y, which I define to be x bar minus a half, not a quarter, it should be a half, guys. I apologize. So the new estimator y is an unbiased estimator for theta, right? Okay? Now let's see whether it's also consistent, right? To see whether it is consistent, we need to work out the MSE of y, right, which is the same as, it's the same as the variance of y, because remember, bias, if an estimator has bias equal to 0, then the MSE is the same as the variance, right? Sorry, guys. I'm really bad at moving things. Okay. So the variance of y is equal to the variance of x bar minus a half. And the variance of x bar minus a half is the same as the variance of x bar, because adding or subtracting a constant does not make a difference to the variance, right? Now, if you look back over here, guys, if you look back what we did over here, right, we worked out the variance of x bar to be 1 divided by 12 over n, 12 times n. So this guy here is equal to 1 divided by 12 times n because of what we did earlier, right? Yes? And this, as n approaches infinity, this goes to 0. All right? Hence, sorry guys. Hence, the new estimator, which I define to be x bar minus a half, is consistent and it's also unbiased. So it has both the good properties, right? The good property of being unbiased, in other words, having a bias of 0, and it also has the good property of being consistent, in other words, the MSE approaches 0 as n approaches infinity. So sometimes it's possible to make a good estimator from a bad estimator, right? Yeah, just like I showed you here. But that's not always possible. That's not always possible, right? As we shall see later, right? Okay. Any questions, guys, so far? No? You sure? All right, let's look at one more example, which is example. Can you guys look at this? Is example 11. I'm doing this, guys, because these examples are not from the problem sheets. These examples 10 and 11 are not in any of the problem sheets. So the reason I'm doing this example is to give you extra, input on how to calculate or how to deal with questions on biases and MSCs, right? Because neither of these examples, 10 or 11, are on the problem sheets, all right? All right, let's look at example 11, guys. Yeah. So you have a random sample from this distribution where theta is an unknown parameter, and we have x bar. X bar is a possible estimator of theta. Okay? Sorry. X bar is a possible estimator of theta. And we want to find the bias and the MSC. Okay, let's look at the bias first. The bias of x bar is yes. Yes. Now, let me ask you, how do you find the expectation of xi in this example? Yes? You guys okay? You are given the density function here. You are given the density function. So to find the expectation of xi, you need to do what? You need to integrate from 0 to theta of x times the density function, which is 2x by you know how, I mean, remember that for a continuous variable, if you want to find the expectation, you just simply integrate the density function. And that's what I'm doing here, right? Okay? So, this is theta squared, guys. The integral of x squared is x cubed by 3, limits from 0 to theta, minus theta, right? Now you get 2, sorry. If you take the limits, you get theta cubed by 3 minus theta. And this is the n, so you get 2 theta by 3 minus theta, which is minus theta by 3. Yeah. All right, hence x bar is once again is a biased estimator of theta. Is that clear, guys? Yes? So this, in this case, you just, I mean, to find the expectation or to find the bias, you need to do the integration, guys, right? So we have a situation once again, just like in the previous example, that the bias is not equal to 0, right? Now to find the, let me put this here, guys. Move this out of the way. To find the MSC of x bar, once again we need to use the formula we need to use this formula that I proved a while ago. So this is the variance of plus the bias. The bias is this guy here. You should square it. You get theta squared by 9. Okay. Okay. So this becomes taking the variance inside. Get this, yeah? Now, to find the variance, remember the variance of xi, I'm sure you know this from a long time ago. you remember this formula, guys, that the variance of xi is the expectation of xi squared minus the square of the expectation, right? Now, we know, if you look over here, guys, we already worked out the expectation of xi, which turns out to be this guy here, right? So we can put it here. The expectation of xi from this line is, just a minute, it's going to be is that right? You should follow the working here, guys. You should follow the working from this line to this line. You will see that the expectation of xi is equal to 2 over 3 times theta, or in other words, 2 theta by 3. Yeah. So this guy is simply So this sum applies only to this, and you have a bracket here and this. Okay, so this becomes 1 over n squared. I know some of you probably got lost already, I don't know. But, I mean, this is just mathematics, guys, right? Right, so if you divide by n squared, you get minus 4 theta squared divided by 9n plus theta squared by 9. Okay. Okay. Now, so what remains to be found is the expectation of xi squared. And to find that, I'm going to use the integration one more time. So to find the expectation of xi squared, I'm going to say it is the integral from 0 to theta of x squared times the density function, which is 2x by theta squared dx, right? All right, now integrating this, if you do the integration quickly, I'm not going to spend a lot of time. So it will be 2n squared theta squared sum from I from 1 to n. The integral will be x to the power 4 divided by 4, limits from 0 to theta, minus 4 theta squared by 9n plus theta squared by 9. Okay. Taking the limits at theta and the limit at 0, you will get this to be you get this to be this. And finally, you'll get theta squared divided by 2 n minus 4 9n plus theta squared by 9. Okay? Correct me if I'm wrong. And this, if you take the common factor, which is 18n, this will be theta squared by 18n. 18 guys here, 18n plus theta squared by 9. I know this is long, I mean, maybe it's boring for some of you, but these are the kind of questions you may get in the exam. Or the, so after a lot of simplification, this is the MSC that you are getting for x bar. Now, as n approaches infinity, this approaches theta squared by 9, which is not equal to 0. And therefore, x bar, the estimator x bar is biased and not consistent. Okay? So once again, you have an estimator that is bad in both respects. It is not an unbiased estimator, and it is not a consistent estimator. Now, once again, can you make this bad estimator into a good estimator? And how do we do that? How can you make, is it possible to make this bad estimator into a good estimator? Any ideas, guys? Sorry, guys. How can you make this? All right, let me show you. How can you make this bad estimator into good estimator? For that, let me define a new estimator, which is, call it, I'm going to define a new estimator to be 3 by 2 times x bar. And let's see that this new estimator is better than the bad estimator, right? To see that, first thing is you need to compute the bias of the first thing is you need to compute the bias of y, there's no y bar, y, which is the expectation of y minus theta minus theta minus theta. Now, if you look back in the calculations we've done over here, guys, we showed that the expectation of x bar is equal to 2 theta by 3. Yeah? So this guy here will become 2 theta by 3. Yeah? Now, what do you see here? This is theta minus theta equal to 0. So y is an unbiased estimator of theta. All right? So in a way, it's a good estimator because it has bias equal to 0, right? Now let's also see if y is a consistent estimator. So to that, we need to compute the MSC. We need to compute the MSC of the new estimator y, which is the same as the variance. Because remember, as I said many times already, If an estimator has bias equal to 0, then the MSC is the same as the variance, right? So this is the variance of, sorry guys, sorry, I'm very useless in this. So this is that, and this is 9/4 times the variance of x bar. Now, you should look back in what we did over here, guys. The variance of x bar is here. And we did all these calculations, and we end up with this one here. This is this one is the variance of x bar, right? So what you have here is 9/4 times theta squared by 18. You guys see this? Yeah? It's 9/4 times. This is the variance of x bar that we computed over here, guys. If you look from the first line, this is the first line, yeah, to the last line. This is the last line. This is the variance of x bar, right? So this is equal to theta squared times 8n. And this, as n approaches infinity, goes to 0, right? Hence, y is unbiased, and hence y is an unbiased estimator, and is also a consistent estimator. Is that clear? So we've done two examples. We have done two examples so far where I have shown how, listen guys please, I have shown how to convert a bad estimator. When I say bad estimator, I mean an estimator for which bias is not equal to 0, an estimator for which the variance or the MSC does not go to 0 as n goes to infinity. So how to convert a bad estimator into a good estimator. A good estimator is one where the bias is equal to 0 and the MSC approaches 0 as n approaches infinity. Yeah? All right. Now, so I spent some time doing these examples. I hope that this would help you to reinforce your knowledge on how to do calculations with respect to bias and MSC. And neither of these two examples, as I said, neither of these two examples are on the problem sheets. So it's on top of what you have done during the example classes. All right. Now, before you go, guys, just don't leave yet, guys. Tomorrow, when you guys come tomorrow, I'm going to start on a new topic. Shh, don't leave yet. The lecture tomorrow from 12 to 1, right, will be on the likelihood function. It's a new thing. I don't know, some of you might have seen this before. Some of you might not have seen this before. And we will also talk about tomorrow about maximum likelihood estimation, right? So we will talk about the likelihood function and the maximum likelihood estimation tomorrow. I'm finishing early today because of the week 3 feedback form. Please, I would really appreciate, guys, if you could take a couple of minutes to complete the week 3 feedback form and return it to me, guys. Thank you. Thanks a lot. Thank you. value of theta. The theta is unknown parameter. So you cannot say that. You cannot do that. Yeah. Yeah. Okay, give it to me. Thank you.